All right, everybody should be seeing the nice little coffee cup on the screen there. If that is the case, we're going to get this thing rolling, and hopefully everything starts working smoothly here. There we go. All right, first, just to give you a little bit idea of who I am. As he said, I'm the sales director with Ducts and Cleats located in St. Paul, Minnesota. I've been working with this outdoor duct type system, pre-insulated ducting, for almost 20 years now, specifically working with phenolic duct. So we're going to talk a lot about phenolic. We're going to get you a good understanding of why it can provide you significant energy efficiency savings and long-term indoor air quality savings. So we're going to kind of go through this. I currently cover the U.S. for Ducts and Cleats and Canada. I do live on the East Coast, so a little different weather there. Not too far from the beach, not too far from Philadelphia, but kind of manage everything through our manufacturer's reps. So a little bit about who we are at Ducts and Cleats. So we are, for almost 60 years now, a sheet metal contractor by trade. That's where we've hung our hat for the last 55 years. In 2015, we started developing, or actually around 2012, we started developing in the phenolic product line. We're a full service, galvanized and phenolic side, stainless steel. We make every kind of duct you can imagine, rectangle, spiral, oval, double wall. And then we have our phenolic duct division. We are a union fabricator in the St. Paul, Minnesota area. Everything we do is sold to contractors. We do not compete in the installation market anymore as a mechanical contractor. We are solely duct manufacturers, always looking to improve our offerings there. We do have a couple different offerings. As I mentioned, we have the galvanized, but we also have an ISO air purification system that the guys in Holden could work with you if need be. But it is a air purifier that you roll into the rooms. It has the HEPA filter, the GPS, and the ultraviolet light. Takes rid of about 99% of the contaminants. Very popular in 2020 and 2021, obviously, but that's gone down quite a bit. But the reason I bring that up, everyone in the shop at Ducts and Cleats is trained on the fabrication of Pro-R pre-insulated duct. That is our flagship now. That is our main product line. And what that means is when we hit the summer months, when things really start getting crazy busy, we can take our full galvanized or ISO air production teams and move them into the Pro-R production, beef up production without trying to add additional training. They're already trained. And then we can fill our galvanized departments from the union hall. So we don't have to train in that area too. That becomes very important for lead times, especially in those April to September when we're really trying to fill those summer months to get schools open in time. So that's who we are. What we do is when you're working with phenolic duct or pre-insulated duct, you do not need to do anything unique or different. You're going to find the same pressure losses as you get with insulated metal or just metal duct. So everything is kind of going to match up exactly. So if you're working on a 20 by 26 duct, the ID of the Pro-R system will be 20 by 26. The only variation would be the OD, and that will depend on the R value that's chosen for that particular application. So we take your engineer drawing. We do not get a takeoff from our mechanical contractors because metal's different. We're working with 4-foot by 13-foot panels. It kind of changes things on the CNC. So we need to look at an entire project and quote accordingly. In doing so, when we provide a quote to our manufacturer's reps like Holden, we provide a drawing like you see there. That drawing goes out with the quote, and it's kind of a checks and balances for us. And the reason is, especially those of you who are really in the plan and spec world, plan and spec world is going to go to the lowest bidder. The lowest bidder is inevitably, I can't even say the word now, going to be the guy who missed the most. And so we want to make sure it's not our product by just saying, yeah, we quoted this job. We actually detail and show, and that allows the Holden representative to verify that we're quoting everything that needed to be quoted. It also allows the contractor to make that same verification. So before you get too down the road, you know you haven't missed anything. When that takes place, the job is sold. We then prepare an engineer submittal for our engineering groups. That will detail the product line. It'll show the same drawing. It'll detail what it's made of, how it goes together, et cetera, to make sure the engineer is getting what he hopefully specified, basis of design Pro-R, or if it's an alternate, it's meeting the specifications that he is requiring or she is requiring. Then we do a fabrication submittal. Now, the fabrication submittal is meant for the contractor. This is more of a detail. This is going to list every single product that we are providing by number. It's going to show the size, the ID, everything that needs to be confirmed and verified. Every piece number is going to be identified that'll match up with the drawing to show where every single piece goes. When you're dealing with phenolic duct, unlike metal, even if you have 7 pieces that are 100% identical, they will each have an individual product ID number so that it goes in a location it was designed for. So that is something that's a little bit unique to us. Once the contractor has verified everything, we will then complete the duct fabrication and we will begin shipping that product to the contractor. If you look at a job like you're seeing here in the picture, oftentimes that's many, many truckloads. So you're going to be shipping and trying to work with the contractor to make sure we're not providing too much material too fast and we're giving the right product when it's needed. So all that coordination takes place. We coordinate training and installing with the contractor, but you're going to see as we go through today, there's very little training required. So let's talk about Pro-R. Let's talk about how we got here. You're going to find it's a proven solution for all HVAC duct applications. We have several different offerings I'm going to go over: exterior, round, double wall, and interior. And we're going to kind of get you to understand why we have this product, why it's in demand, and why it's growing so fast here in the US. So first of all, let's look at what we do. The industry average way of doing exterior duct systems has always been insulated sheet metal. Now that means that they're going to install ductwork. They're then going to have a field insulator come out and install the insulation. That insulation gets wrapped around the duct, then a jacket gets applied. Most of the time, way too often, it's an open cell insulation that absorbs moisture like a fiberglass. So I kind of want to throw a concept to you. Every time I say the word insulation out there when we're talking about metal, kind of replace it with sponge, because that's virtually what we're doing, is putting a sponge around that metal duct and then putting it outside. Once that gets wet, it will absorb through that insulation. Then you start to have the mold and mildew. And this is where the real problems evolve. And this is where we need to focus. We need to stop that. We also have thermal bridging at the joints because the flanges rarely get insulated in the field unless you're mechanically engineering it as such. And then there's a lot more heavy weights. Oftentimes those duct supports are inside the insulation, which create even more thermal bridging. So it becomes a real issue, but it's what we've been doing for the last 30 years. It's what we understand. And so that's how we've been doing it. Now, over the years, we've used various cladding material between metal. We've done mastic. We've done EPDM rubbers over the year, roofing membranes, plastic, all kinds of different applications to jacket that insulation, thinking it's going to solve the problem. Unfortunately, to apply those systems, we're dependent on either glues or screws to penetrate that jacket and kind of hold it together. They're very dependent on sealant, and that sealant is often exposed to the elements, which is going to create additional problems. The insulation, because it's open cell, will get compressed when people walk on it or pull it tight around the duct systems like you see in the bottom left corner. In order for an insulation material to work as identified in ASTM 518, which is our testing for thermal value and K factor, that insulation has to be fully expanded. Now, when what I call the Bubba factor. When Bubba walks on the duct, he's going to compress that insulation. It's going to lose thermal value. If it's got moisture in it, it's going to stay down and it's going to create additional problems. Even that indoor application in the bottom left corner, you can see where it's pulled tight around the corners of the duct, where it's pulled tight around the flanges, where it's pulled tight with the wires holding it on. If you just look at that, you would think, well, that looks pretty good. But in actuality, that has very minimal R value on the flanges, where the wires hold, and around the corners. So on an indoor application, it's not quite as critical, but on an outdoor application, it becomes very critical. And then you get a lot of hidden damage underneath that you can't see, again, especially on the outside. And one of the benefits that you're going to see, and this is going to really benefit a GC and the production of a project, is that you're always dealing with two trades with the old metal. You got the sheet metal guy, and then you have the insulator. Well, what we're providing is an opportunity to eliminate the insulation trade. And you can deal strictly with a sheet metal trade to do everything. Historically, what we've seen over the years is that we will have engineers specify higher thermal values on the external application of the insulation. Right now, the zones around the U.S. are going to range from R8 to R12. Probably there in Atlanta, most of you are specifying R8, although many have gone to new codes, which are R12. But in some of the cold or really cold environments or really hot environments, they will go to the R12. But this increased insulation does not address the real problems with insulated metal. So it doesn't really solve the problem that we think we're having, where the insulation's getting wet and collapsed and moldy and mildew. If you just think of it as the concept of wet insulation, in other words, that moisture has gotten into that sponge. If you have a 3-inch thick sponge versus a 2-inch thick sponge, it just holds more water. So it really didn't improve the insulation once it started to get wet. And the number one problem is that we allow duct leakage. In fact, SMACNA calls it allowable or acceptable duct leakage. Your typical metal duct system, if installed per SMACNA standards, will leak at a Class 6 rate, or 6% leakage at 1-inch static pressure per 100 square feet of duct. Now, that's just using your standard SMACNA guideline to install duct. And they basically said, if it does get installed the way it's supposed to, we're going to allow 6% leakage. The problem is, if air gets out and your duct is exposed to the elements, water gets in. It's just natural science. Part of the problem is we're still running off the 1985 adaptation that sheet metal SMACNA did from adopting the European standards back in the day. And this is where we kind of determined, based on what they were doing, that it didn't benefit to improve that leakage. Well, now we've started to look a little more at what the real issue is. And that's when the duct is leaking and you've got wet insulation, you have three major issues. Structural integrity of the system. You start to get galvanized duct that begins to corrode and rust. This begins to leak inside the building and cause other structural damage. You have energy efficiency, because wet insulation is 85% ineffective as a thermal barrier. So once that gets wet, now you've lost the thermal efficiency you were trying to gain in the first place. And now we start to develop mold and mildew, and this creates an indoor air quality issue that evolves to where it's in the building, it's in the airstream, and it's starting to affect employees, etc. So it becomes a big issue. The cost of leakage is going way beyond just the cost of that CFM. And so now even SMACNA is starting to evaluate and say, we need to tighten these up. Because the first cost, the value of the CFM, if you look at it, somewhere between $400 and $650 a CFM, depending on what part of the country you're in. Yeah, maybe it doesn't cost to try to solve that. But then when you start looking at the fact that you have to replace that cost, many of us will upsize units to allow for allowable leakage. So maybe you can stop the leakage and minimize that. We've done it in the units. We've tightened up our unit specs. We've tightened up leakage. We've tightened up insulation. But then we hook it up to the same old duct system we run across the roof and allow it to continue to have the problems it's always had. You've got reduced thermal value that has to be made up. Your 60-degree air isn't entering the building at 62. It's entering at 68 because it's losing too much. Then you have possible replacement of duct, you have maintenance costs, you have indoor air quality, health concerns, and then of course you get the ancillary damage. Excuse me. If you look at that picture to the right, many of us would say that bubble there has great concern for us. And we start to panic because we think, well, now our duct is leaking. Well, keep in mind, the duct is always leaking, 6%, 1-inch static pressure. So we know the duct is leaking. So when we see these types of applications where it bubbles, in fact, we used to see it a lot with EPDM rubber especially, that's actually when it's working, believe it or not. That means the air is not getting out of the insulation. And so if it's not getting out of the insulation, it's not allowing water infiltration, and it's basically reaching a holding point and stopping. But you know what they'll do? They'll come along and they'll poke holes in this so that it doesn't look like it's leaking. And so then you start to have bigger issues and bigger problems. So then we have to address the challenge of how do you quantify the value of that leakage if it's not just the CFM? Or how do you go beyond that CFM? How do you even evaluate the cost of that CFM? Well, you have to do a couple things. There's 3 major areas of energy transfer that we would have to focus on: radiation, conduction, and convection. Now, radiation is going to be the effects of the sun. Conduction is going to be the value or efficiency of the thermal barrier we put around that system, how it can lose through that material. And convection is going to be the actual loss of the air movement itself. Now, believe it or not, we can look at that with an energy calculator, but we have to look at a lot of different parts of that moving system. We have to look at weather data, SMACNA leakage data. We have to look at utility costs for gas and electricity. We have to look at the ID duct surface of each individual system, the conductions of energy impact, the temperature gradients, insulation performance, system area and insulation continuity, coefficients of heating and cooling, how much is cooling, because obviously Texas is not going to be the same as Boston. So all these fan losses, radiation energy impact, this all has to be evaluated. And believe it or not, there are formulas that we can do all that. We can configure every single piece right down to the end to try to figure out what we need to do and what the effect of that energy loss or that CFM loss, what effect it is going to have on us. So when we start looking at that and we put it all together, we start to realize that if we just simply reduce leakage from 6%, your average metal duct system. And let me just point out that SMACNA says that if you install duct this way, it'll average that 6% leakage. Now, that's assuming that it never gets worse. And let's keep in mind when duct expands and contracts, when the separations to the duct begin to take place, this leakage gets worse. And in many times, if you require a leakage test, and most of the time it is not required, that test is done before you even connect the duct to the duct supports. Why does that matter? Well, typically duct supports will screw into the duct. Every time you penetrate that duct, you create a little more leakage, and that can get worse and worse over time. But just looking at a 23,000 square foot duct project in Minnesota, just comparing a 1% leakage to a 6% leakage, we're going to make some assumptions. It's located in Minnesota. We're going to assume a 3% energy inflation over 10 years. We're going to assume an R12 thermal value because that's what's required. And even though we're comparing an insulated metal to a phenolic system that we're going to offer with Pro-R, we're going to assume that the R12 insulation put on that metal never loses thermal value, never gets wet, never breaks down, never gets compressed. It's R12 from day one until 10 years later, the way it would be with a pre-insulated phenolic system. And then we're going to assume a 50% runtime. The total 10-year savings on that project is going to be $188,000 in energy efficiency savings only compared to an insulated metal system, just by going 6-inch down to 1-inch leakage. And that's going to vary depending on the area, but that is strictly looking at the efficiency of the system. And it assumes that everything remains constant, which we know would not be the case. So now we're going to talk about Pro-R. We say forged in thermal protection because we've been doing this for many years, and we started to understand where the problems were and how do we fix them. And you're going to find that this is a proven solution for all HVAC duct applications. And let me point out that we focus primarily on the outdoor application, although we offer indoor. The reason we do is because we are providing a solution. I think most of us would admit that insulated metal on the outside, exposed to the elements, has a 100% failure rate, always, because we're allowing it to leak, and then air is going to get in. And so we also need to understand that when doing these kind of systems, and you get that call back where the owner says, hey, I've got a problem with this duct system. It appears to be leaking. The insulation's wet. It's holding water. Now we get into the finger pointing between the two trades that did that job. Did the sheet metal guy do something wrong, or did the insulator do something wrong? And I would stand by most of them that neither of them did anything wrong. The sheet metal guy did what he was supposed to do. He followed the SMACNA duct standard. His duct is allowed to leak. Even if you didn't test it, it probably leaks 5, 6, 7, maybe 8%. If you look at the insulator, his job is not to hold leaking air in. His job is to insulate the duct system to the best of his ability. So he's going to insulate what's already been installed. He's going to go around thermal breaks like the duct supports. He's going to go around all the holes. And now air is going to get out of that duct system. It's going to be in the insulation. It's going to follow the path of least resistance. And now water begins to infiltrate. So in reality, nobody did anything wrong. So let's start talking about phenolic pre-insulated duct. You may or may not know Kingspan Cool Duct. They are the only phenolic duct in the United States, the phenolic board cool duct system. They've been around since about 2004, but they are the only one. In fact, they're headquartered out of Atlanta there for North America. So it is a great system, and it should be used indoors more often as well, but we don't have as many problems indoors. But it's a very rigid, high-performance phenolic board. That phenolic is closed cell. That means it has a 0.14% absorption after 24-hour immersion. Now, that means if I hold it underwater, it's only going to absorb 0.14%. So even if I compare it to that fiberglass sponge insulation, if the water gets into our system, it doesn't absorb into the insulation the way it would on that fiberglass. It's fiber-free and odorless core. It's phenolic sandwiched between two 25-micron aluminum scrim-reinforced sheets. So in essence, when it becomes a duct system, is a double-wall duct system. Metal on the inside, metal on the outside, insulation on the inside. There are 3 basic values in thermal efficiency. 22 millimeter is our 6. This is going to be your typical standard indoor application. Sometimes it's used outdoors when it's on exhaust and they want to insulate the exhaust duct a little bit. R8 is 30 millimeter and R12 is 45 millimeter. Now, 45 is 1 3/16. R8 is 1 3/16. 45 millimeters is 1 3/4 inch. You're going to see as we go through this that there are multiple product names that you may recognize that are phenolic duct systems. They're all using Kingspan Cool Duct as the core. What they do with it after that makes it their own patented product, like our Pro R system. But we're all using the same exact board because it is the only UL listed phenolic panel in the United States at this point in time. There was another one I'll touch on here in a minute, but right now that is the only one. And what makes this board so unique is that it meets the ASTM E84. This is your 2550 smoke and flame. That means it can go against the airstream. It can go inside the building envelope. Things that other closed cell insulations like polyisocyanurates or polyurethane boards, they cannot do because they do not meet that smoke and flame. Understand as well that this Cool Duct board is a UL 181 listed system, not just a board, but a system when installed properly and designed and built per SMACNA standards. It is a UL listed system. This is important. I'm assuming many of you on here today will end up going to the AHR show in Chicago in a few months. And when you do, you'll walk the floor and you might see other phenolic panel systems out there. If they are already in the United States, it's probably an external application system that's using the cool duct board. But if it's a new product from China, Venezuela, or one of the other countries that Italy that produced P3 or these other product lines, they are not in the United States because they are not UL listed. They will say they meet UL, but that means they tested it. If you are UL listed, that means UL tested you. And most of them don't meet the smoke and flame, so they're not in the US. Says LEED eligible. In fact, it was used in 2004, 2005, when NOF Insulation first brought cool duct into the United States. And it was used in the U.S. Green Building Council in Washington, D.C. for platinum LEED certification. Now, it was developed in 1992 in Italy. NOF, the fiberglass folks, actually brought it into the U.S. in 2004. They had a 3-year exclusive agreement. The goal, the concept was to get contractors that typically make sheet metal to start making this phenolic duct system cool duct. NOF Cool Duct had the exclusivity. I started working with them in 2006, setting up master distribution network, assigning contractors, etc. But in 2007, Kingspan from the UK purchased that brand from PAL, who had created it. And then they too came into the United States. Now, in purchasing, they had to honor the agreement with NOF and supply NOF with their material. But then they came into the US and we helped set them up with master distribution networks. It made the industry think there were two product lines, NOF Cool Duct and Kingspan Cool Duct. But they were, in fact, the exact same product with a different sticker. That was really the only difference. In 2009, we set up a master distributor in Ohio, and they started developing a product called Thermoduct. There was another company out of Delaware that created a product called Dual Tech that I helped create back when I was their VP back in around 2008, 2009 as well. And the development began on these products. Now, in 2010, NOF Insulation just no longer wanted to work. They didn't play well with Kingspan. And they basically walked away from their $10 million investment, even though they had gotten it into the United States. Kingspan then expanded, took over. In 2015, Ducts and Cleats, we had been developing and working on that Thermoduct product and Cool Duct for about 3 years. And we started developing the Pro-R system, more to compete with a product called Q-Duct that was brought into the US using PAL phenolic, a different phenolic made in the Middle East. I was with AQC at that time. We bought that product in and we developed a product called Q-Duct, an interlocking system. However, in 2022, in July of last year, that product was discontinued in the US. Kingspan had bought the company PAL, and so they only wanted one brand in the US, and so they stopped bringing that into the US. And so Pro-R then expanded nationally, and that's where we are today. So a little bit of history. As I said before, I've been doing this for a long time. So let's talk about what we are bringing to the table at Pro-R. Our number one product line, Pro-R Rectangle. That's our outdoor line. That's going to be exposed to the elements 95% of the time. We do projects on the inside with it, but that means you want a coated jacket over the phenolic. It doesn't need a jacket when it's inside. We do that typically in clean applications. So we just did a big job in Florida where it was a cafeteria kitchen area and they knew it would get greasy. They wanted to be able to wash it down on the outside every so often and make it look nice. Pro-R Round is pretty much what we're going to talk about in a round application. And then we have two specialty offerings, Pro-R Indoor, where we've kind of beefed up just Cool Duct by itself to allow higher pressure classes, and Pro-R Double Wall. So talking about each, you're going to see that they're designed for maximum durability and efficiency. They're lightweight. They're very easy to install. They're about 70-75% less than insulated metal. We have several thermal values. Remember I said R6, R8, R12. Well, that's the thickness of the board that are available in the United States. We do offer higher R values, but in doing so, we are multiplying boards. We're doubling up the boards that they make. We're not getting thicker boards. What we're able to do at Pro R is we get less than 1% leakage on average. We'd like to say, you know, every job should be less than 1%. We always want you to do a leak test. We want you to test us and challenge us as well. We're confident, and I'll explain why we're easily there. We offer a 10-year limited system, 10-year limited warranty. You're not going to get that from a sheet metal contractor. And then we follow, SMACNA put a standard out in 2015 for phenolic duct fabrication. So we follow those SMACNA standards. Some of competitive products out there will not do that. So you have to be careful there. So rectangle, it's just your basic exterior application that's going to be exposed to the elements. When we go round, we do it a little differently. You could call it a double wall. We do not. We put a galvanized spiral on the inside of that duct. We have a spiral machine for up to 60-inch. The reason we do that is because if you look at phenolic systems out there, they have to be V-grooved to make the cut. So when you're doing rectangular duct, you make 4 Vs, fold it, and it kind of supports on itself. Well, when you do round, you actually get 16 9 degrees, let's say. And so it starts to get these little bends, and then you fold it, and it comes together at each location. But if you push down on it, those little spots can open up. So we started adding the galvanized spiral on the inside. This gives it strength, extra durability. It allows it to withstand weight loads, especially when it's outside. We realize it doesn't get a ton of weight the way rectangle does, but it still needs that extra protection, and it provides that little additional airflow. Our double wall system is Pro R rectangle, but with a little catch, we add an internal duct, much like you saw on the round. Only for rectangle, we usually don't need the galvanized because we've shifted to an aluminum surface in there. So we're going to leave it as aluminum. When we do a double wall, that's typically because we need a stainless steel liner. So this gets used less frequently. It's more for heavy chemical exhaust that would not play well with aluminum. So we will use the stainless, or it's either a surgical, medical, or food grade application where it needs to be continually cleaned with a wet clean on the inside. So we'll put a stainless steel, can be welded, could be flanged, whichever the case may be. Then we look at our Pro R indoor. We take the Cool Duct product, which is sufficient by itself as an indoor application, and we reinforce the corners, the horizontal corners, by putting 2-inch angle on the corners that tie into a TDC type flange that allow this system to be stronger and more durable. Again, insulated metal is going to be less expensive, but if you have space saving concerns, you're looking for indoor air quality, energy efficiency, it's going to be the better way to go. So let's talk about some of the unique features you're going to find with Pro R. So first of all, we put an 040 aluminum embossed Kynar finish. So that's an 18 gauge aluminum. Keep in mind, if you emboss the metal, it makes it about 20% stronger. So it's very strong and durable. It will be the thickest jacketing on an exterior application on the market. If you're doing insulated metal and you're putting metal on that with an insulator, 80% of the time he's using an 016 aluminum. Now this would be aluminum you can do around a chimney, or you can kind of bend it without even a brake, although they would use a brake. But then they're going to screw it or rivet it together. These create additional penetrations. Sometimes you'll go up to an 032, a little more durable. Probably 20% of your insulators are carrying that kind of brake on a regular system. One of the other features, and this is one of the ones that start allowing us to meet that 1% leakage, is our Pro R system is a double duct system. So we build Kingspan Cool Duct. We follow SMACNA standards, ANSI 22, and we build a duct system. Now that's important because anytime you have to, based on the size of the duct or their pressure class, you have to add reinforcement tie rods on the inside. You must have the tie rod, I'll show you here in a second, with a metal plate on either end of the tie rod. Then you're going to go outside of that phenolic duct, put another metal plate and screw through and bring it all together. So you're sandwiching the foam on both sides. So we want to make sure all that is done to the cool duct prior to us building a second duct, an aluminum exterior duct per SMACNA standards for metal duct. This really works out well when you're doing chase penetrations and you've got to build 10, 12 feet at a time and kind of drop it down in. You'll see that having this double duct system really helps with that. We use an integrated 4-bolt TDC flange. Now, what that means with a TDC flange is that that flange is going to fold up and become part of the flange, our external jacket. Whereas most systems glue the duct panel to the plastic or venture-clad or whatever kind of jacket they're going to use, it ends at the flange. So when water gets underneath the flange caps, it can get in the system. Our system takes away all those seams that would normally be around the flange. Then we back it up with a double gasketed system. So every contractor knows how to use butyl gasket. They're putting that in every flange on every system they do everywhere. What we've done is added a neoprene memory gasket on the internal side closest to the airstream, so that when that system is bolted and clipped together, air flows over smoothly. There's nowhere for it to get out. If by chance it breaks out of that memory foam, which will expand any opening, it can't get past the butyl. So that and the duct system allow us to get to that less than 1% leakage. And one of the key elements is those Pittsburgh seams we use when we're building the metal jacketing duct. So a Pittsburgh seam, you're going to have a sealant, and it kind of folds in, so you get 2 levels of sealant, and then it hammers that down. So we never have glued panels together. We're always building a duct around our phenolic duct. Those are the things that make us really unique to our competitors. All right, we addressed the 3 types of heat transfer that we mentioned earlier. Part of that is going to be with the radiation to affect the sun. We're generally going to quote it with a white. Although we have 4 different stock colors. We quote it as a stock color, but we want to reflect that sun. Conduction, we've got a solid closed cell cool duct foam. It's not going to allow the loss through that material. And then convection, we're going to simply tighten up that system and have it at less than 1% leakage as opposed to 6. Now, this will give you an idea of the strength. There on the left, you can see there are 4 of us standing on that duct. That's 800 pounds roughly. You'll notice that inside there is what we call an air truss. Remember I said you had to have a 3-inch plate on either side of the tie rod? We created an air truss. That air truss bends up and then double bends back down, gives it additional strength as a standard metal bar, if you will. And what that does is help cantilever out some of the weight distribution so that it's not going to sag in the middle the way metal duct does if somebody walks on it. This will also give you an idea of the durability. Kind of watch how the duct bounces. It'll give you an idea how hard I'm hitting it. All right, so here you can kind of see that even if you look at this, there's little dimples, but you're not penetrating the duct. You're not getting to the inside of that duct. So if you were to do that to any other system out there, insulated metal or any other phenolic, you're going to create openings that are going to allow water penetration. Color options. We have multiple color options, as you can see. 4 are stock colors. We have white, we have almond, we have Sierra tan, and we have cityscape gray. By stock colors, we mean these are coil lines that we maintain. You could jump from one stock color to another. We're going to quote every job with a stock color. And then the architect could choose later. And as long as he's jumping from one of those 4, it won't affect anything. Now, if we have to go to a different color, say a colonial red, that might require some lead time. That might require some additional cost. Just depends how early in the process that color is identified. Because we don't keep those coil lines. We have to order them from our manufacturer. We get them in 4-foot by 10-foot sheets. So it changes a little bit. But as long as we know early in the game, it usually doesn't have an effect. The other thing we can do is sometimes we'll get a unique university application. And I don't want to pick the wrong university here. So let's just say we have a university color that doesn't fit this chart here. Each color would have a 3-digit code that you could give to a Sherwin-Williams or Benjamin Moore, and they can match that color exactly. And then we would coat it with a galvanized paint grip jacket that could be painted in the field by the contractor to match that exact color. Application, we go over this quick start guide, but again, there's not a lot of difference to what a contractor does every day, with the exception of adding the neoprene gasket and putting a flange cover over that duct. As far as duct supports, we don't want to screw into the duct. We're going to fully encase it around, which is the way it should always be done. Should never screw into your duct system. It's going to allow leakage, and if it's outside, it's going to allow water penetration. But we kind of go over that. Typically, we say about every 8 foot in spacing between duct supports. SMACNA standard will say if it's 88-inch girth or less, you can go to 13 feet, which is fine. And then you'll put it under every elbow, every transition. Again, these are things that we go over during training with each and every contractor. Access doors, they can be cut in the field pretty easily. We tell them how to do that, or they can be sent to us and we'll install them in our shop if we know where they're going. Wall penetrations. Obviously, we don't want to cut a hole the size of a flange. We want to cut a hole the size of the OD of the duct. So we'll leave a flange off. We'll allow that duct to penetrate through the wall, and then they'll be able to put like a duct mate flange on the end for connection to your sheet metal or your sock or whatever you're connecting to. This is the same process we use if we're trying to release a project and an air handling unit is not in place, and we can't shore up that final measurement on that last straight piece to the transition piece, because depending on where the unit sits, it could be off an inch or two. So we might take a 24-inch section of duct, make it 36 inches, leave off the flange once again. They'd be able to field measure, get an exact cut once the unit's set, and they'll be able to put that flange on and seal it. That would be one flange. That would not be a TDC flange. Roof curb, again, same as what every contractor does every day. You've got a little S channel in there that secures to the curb and to the duct. It sits on top, and all is well. So as we bring it to a close here, let's understand the competition. There are other phenolic systems I'll mention here in a minute, but they all depend on some kind of cladding glued to the cool duct panel. So that means penetrations often go through the phenolic for those tie rods and also through the external jacket. Well, these are going to allow water to get in. Most, in fact, all of them don't offer a TDC flange the way we do, that's integrated into our duct jacketing. And so that allows water if it gets under the covers. In fact, you can see in the top right corner, that cover, that's a product called Thermoduct. It's got to have sealant down both sides. And so if that sealant has any gaps or breaks, it's going to be a problem. It's going to allow water infiltration, and that's part of the issue with it. You can kind of see in the top of that same picture where the tie rod came through the outer jacket, and they have to put a plastic cap, and again, hot glue and sealant to try to close that off. They're very dependent on sealant. They're very labor intensive. Flange cover caps are intensive because you have to seal them on both sides. And a lot of times they're dependent on screws that will penetrate into the internal side of things. So obviously our number one competition as we look at it is insulated double wall or galvanized duct. And this is just because the way it's designed, the way it's built, it simply does not have the aesthetics. It doesn't hold up well because the air gets out, the water gets in, the insulation gets wet. We start to have issues with performance, with quality, with aesthetics. So these are all the things we already know. We're used to that. We have the Cool Duct product, and Cool Duct by itself, as you see there, that's not reinforced in the corners, is virtually fine for outside. The way the SMACNA standard reads is you must put a jacket on it of some type that will be weatherproof and will shield against the effects of wind and sunlight. You as the engineer are left to make the decision of what that could be. And then you got to find contractors that deal with just that product. But most of us that deal with the Cool Duct have a external application. There are only two national product lines out there that are throughout the United States. One is called Thermoduct. It's a good product. We used to make it. And the reason we got away from it is it's still, while it addressed most of the issues with insulated metal, it didn't really stop the leakage. And because it was so dependent on sealants and glues, it became very labor intensive, and it still allowed the water penetration. Keep in mind, the water didn't get inside the insulation, but it could get inside the plastic. It could get inside to the internal airstream. So we tried to get away from that. There's another product that was created that I helped create, I mentioned earlier, down in Delaware, called Dual Tech. You may see that from time to time. Again, decent product, but it's a cool duct system with an 032 jacket screwed to it all over the place. So it's very heavy. There's lots of penetrations. The internal joint has to be sealed just like you do with metal. And so it too has its difficulty and its challenges. And then we're starting to see where you'll see cool duct lined metal. And it's need to understand that if it's a lined metal system, it's not a cool duct system. Doesn't mean it's not going to help. It's just not, it's going to have the same issues as any metal duct. It's galvanized, it's going to rust, it's going to be exposed. You really need to put another jacket on it to protect it from the elements. It's going to be heavy galvanized, and it will have penetrations with turning veins like you see there in the corner. These are all going to allow leakage and water infiltration, very similar to the Thermoduct. So I think you'll find that the Pro-R is your innovative solution to exterior ductwork challenges, but it does come down to how it's specified. We've done projects all over the country now, and just our short growth. We've done a ton over the last 7 years in Minnesota, Iowa, Nebraska, North Dakota, South Dakota. Projects like the Mayo Clinic, who specifies us pretty exclusively, Iowa State, 3M, Daikin, a lot of hospitals, a lot of schools. So we've had some great success. The main thing we do is we stop the leakage, because if duct leakage gets there, you're going to have loss of CFM. You're going to have moisture in the duct, which is going to give you ineffective insulation, indoor air quality with mold and biological growth, and you start to have duct corrosion. So these are all the things that we've been able to get away from with the Pro-R system. We do focus a lot on architects and engineers, because there's always an insulated metal option that will be less expensive. I like to say cheaper, because it will in fact be cheaper. It will not work well. Very few, well, you won't find any contractor that's going to give you a 10-year warranty the way we do. That's doing insulated metal, because it just simply doesn't work. And we know that, and it's proven itself year after year. The key is being specific in the product and performance specification. Obviously, I would like everyone here to be specifying Pro-R as your basis of design, but there is in fact a reason for that beyond just I like my product to be basis of design. One is if, let's say, you are going to want the phenolic duct, but you're also going to allow an insulated metal option if they do certain things. If they tighten up the leakage to less than 1% and pass a Class 1 leak test. If they only use TDC flanges, if they only use closed cell insulation, polyisocyanate, etc. And if they require, they're going to put their duct supports outside the insulation. So now you're starting to get a similar comparison to the product line. But if you still continue to make the metal as the basis of design, and then allow the phenolic Pro-R as your alternate, what's going to happen is the mechanical contracting group is going to see a job. They're going to bid a job. They're going to hand the entire package to an insulator. They're going to get an insulation number that is the indoor, the outdoor, the pipe, the refrigerant, everything all into one. And then they're going to say, well, maybe I can talk to Holden. We'll get this Pro-R number. So I'm going to go back to my insulator and say, hey, what's the credit if I don't give you the rooftop duct? Well, at best, that's going to be 50% on the dollar, 50 cents on the dollar. But if Pro-R were the basis of design, and insulated metal, again, less than 1% leakage, 10-year warranty, TDC flanges, closed cell insulation, supports outside the insulation, and no penetrations allowed to the duct, and that's the alternate. Well, now from day one, they always want to bid with plan up with basis of design. So they're going to have that insulator break out and give them a separate ad number for that rooftop duct. Now you're going to see real numbers and you'll have apples to apples in quoting. So that's kind of bringing us to a close here. Final comment, and I'll turn it back over to Tracy, is just keep in mind the bitterness of low quality remains long after the sweetness of the low price is forgotten. And generally, we're talking 10 to 15% plus or minus. If you're looking at an insulated metal of comparison with a closed cell insulation, but if you add the other things in there, it'll even be greater and a much closer in price variance. And it also depends on the size of the job. ProArs, because it's 70% less weight, will install roughly about 50% in less time than it would take to do an insulated metal job. So if the mechanical's planning for 4 weeks, he's probably going to be done in 2 weeks installing our system. So you start looking at the overall install cost. Generally, we're going to be less expensive, but we just have to get them to that point first. So, Tracy, I'm going to turn that back over to you and questions or whatever we want to do here, however you want to handle it, and I'll stop my sharing so you can take over.